Bismillah Rahman Rahim. Welcome to this lecture on data analysis, and in today's lecture we will discuss some basic concepts. So these basic concepts will include mean, median, mode, dispersion, absolute and relative dispersion, measure of dispersion, range, mean deviation, standard deviation, and variance. Okay, so we have already discussed central tendency in our last lecture, so I will go through it quickly. So central tendency is the way in which quantitative data tend to cluster around some value. A measure of central tendency is any of a number of ways of specifying this central tendency. So central tendency have these three measurements. We can use central tendency through calculating mean or average, and we can also do it through median and mode. So one point is to be noted that these three are not same things, but these are used for computing central tendency. Okay, so you already know what is mean. This is the average of a given sample. Let's say we have this is sample 1, sample 2 up to sample n, and this is the total number of samples. So on the average of the sample is called mean, and this is summation of xi, where I start from 1 up to n, divided by total number of n. So this is sample. This is the most common measure of central tendency, and it is affected by extreme values. Yes, if there are, let's say we have total 10 values, and the 9 values are between 10 and 20, let's say, and there is one value, one sample where the value is, let's say, 80. So the average will be affected by this one extreme value, or which is also called outlier. Okay, so this is 5 is the mean, but let's say if we have another value of 14, so now the mean will change, and it will be 6. Median, so median is the middle number. This is not affected by extreme value. For example, in these values the median is 5, and in these value the median is again 5. So median is not affected by the extreme values. Mode, so mode is value that occur most often, not affected by extreme values. There may be no mode, there may be several mode, because this is the frequency, the number of occurrences. For example, 1 is occurred once, 3 is occurred once, 5 is occurred twice, 9 is occurred thrice, and 12 is occurred twice. Okay, so here the mode is 9. Now there is no mode because all samples are the frequency for all the samples is 1. So there is no mode, and there can also be more than one mode. Okay, so now, which measure of central tendency should be used? So the measure you choose should give you a good indication of the typical score in the sample or population. Okay. Okay. So these are the different measures for central tendency. Mean. So these are the different examples. So I hope you already know this. This is mean. Median is not sensitive to extreme values. We have already discussed. Mode doesn't involve any calculation or ordering of data. It is used when you categorize. Okay. Now the next important points are dispersion. So what is dispersion? Dispersion is the distribution of values around some central value, such as an average. Distribution of variable tells us what value and how often they occur. So it means that in distribution, a distribution is related to the frequency of a variable. What is frequency? Frequency is the number of occurrences. Okay. Now, for example, we have these different samples. Let's say these are student number. We have 20 students, and these are the age values of these students. So the distribution would mean that, let's say, students with age 17, the number of students with age 17 is 1, the number of students with age 18 are 2, the number of students with age 19 are 4, the number of students with age 20 are 9, to the age 21, the number of students is 3, age 22 is 2, and so on. Okay, so now here we can calculate the mean, median, and mode. Okay, so mean would be the average value, median is the, we will sort the values, and the middle value will be median, and mode is here, let's say the age 20 has occurred 6 times, so the mode is 6. Okay, now the next points are absolute dispersion and relative dispersion. So absolute measure of dispersion use the original units of data and are most useful for understanding the dispersion within the context of your experiment and measurements. Absolute measurement of dispersion include range, deviation, mean deviation, standard deviation, and variance. We will discuss these in coming few minutes. Okay, and now a relative dispersion or relative measure of dispersion are calculated as ratios or percentages. For example, one relative measure of dispersion is the ratio of the standard deviation to the mean. Okay, so like the ratio between the standard deviation and the mean. We will discuss how we compute standard deviation in next few slides. Okay, but these are the ratios. Relative measures of dispersion are useful for making comparison between separate data sets or different experiments that might use different units. So now the examples will be for so these are, let's say, the absolute dispersion and the relative dispersion would mean that, let's say, these values or for the students of one class, and if we have samples of another class, and then we can compare the mean value of this class with the mean value of the another class, the median of this class with the median of another class, and so on. So these are comparative calculations. The relative measures are the comparative measurement between different data sets. Okay, so relative measures of dispersion are useful for making comparison between separate data sets or different experiment that might use different units. Okay, so these are just comparisons. Okay, now range. So what is range? It compares the minimum score with the maximum score. Okay, so maximum score minus minimum score is equal to range. It is a crude indication of the spread of the scores because it doesn't tell us much about the shape of the distribution and how much the scores vary from the mean, but it is just a simple calculation between the minimum value and the maximum value. Now, for example, in these sample set, the minimum is 12, the maximum is 22, so range is 10. Okay, so this just tell us the minimum and the maximum value in a given sample set. Okay, now mean deviation. So what is mean deviation? The mean deviation is defined as a statistical measures that is used to calculate the average deviation from the mean value of the given data set. Okay, so these are important aspects. The the average deviation from the mean value of the given data set. So we will be having mean value, okay, and then average deviation. Okay, so the mean deviation of the data value can be easily calculated using the below procedure. Find the mean value of the given data set. Let's say we have these data sets and we will calculate the mean of these values. Now subtract the mean value from each of the data values given. Okay, so we will be having mean, and we will subtract mean from 20, subtract mean from 17, mean from 21, mean from 21, mean from 21, subtracting mean from 23. So like mean will be subtracted from each of these values. Okay, so mean is m, and uh, subtraction of mean from value 1, this is what I already said. So we will compute these values for all the samples. And mean deviation, so mean deviation, we will take mean of these values, so this will be mean deviation. Okay, now variance, what is variance? The fact or quality of being different, divergent, or inconsistent. Okay, so variance is a measure of dispersion, meaning it is measure of how far a set of number is spread out from their average value. Variance measures how far each number in the set is the mean, and thus from each other number in the set. Okay, so variance is usually in statistic, it is represented by this sigma square. And how we calculate the variance? So find the mean, the simple average of the numbers, and then for each number subtract the mean and square the result. Okay, and then work out the mean of those square differences. So again, here we have these different steps. The first one is we will calculate the mean of all the samples, and then the next is subtracting the mean and squaring the mean. Okay, so like we will calculate the we will subtract mean from 20 and we'll square that value, subtracting mean from 17 and squaring that value, subtracting mean from 21 and squaring that value, subtracting mean from 21 and squaring that value. And we will repeat this for all the samples. And then what we will do, then work out the mean of those square differences. So in the last step, we will compute the mean of those square differences. So it will gives us the variance. And now standard deviation. So standard deviation is the average deviation between the individual scores in the distribution and the mean for the distribution. It tells us what is happening between the minimum and maximum scores. Now, the method for finding the standard deviation, so it is up to these steps. These are the steps for calculating the variance, and this when we add this fourth step, so this gives us standard deviation. Like finding the mean, this is what we did in variance. Then for each number subtracting the mean and square the result, this is what we did in variance. Then work out the mean of those square differences, this is what we did in variance. And then in the last step, take the square root of that mean. Okay, so this will gives us standard deviation. Okay, thank you.